Hello students, now in this video let us start the variance and standard deviation. Variance and standard deviation. So now what does they? Let us define them first of all. Variance is defined as the arithmetic mean of squared deviations of given set of observations from the arithmetic mean x bar. It is generally denoted by sigma square. This is notation is known as sigma square is the notation for this. Now what does this exactly? Now arithmetic mean of squared deviations of a given set observations from the arithmetic mean means what does this exactly? Suppose x1, x2, x3, these are what the observations given to us. We have found these observations are given to us and we are finding it x bar means what? The arithmetic mean of them, summation xi upon what? N. We have found it. Now n observations are these. Fine. So what is sigma square? For sigma square we are obtaining deviations. What are deviations? The deviations are what here? x1 minus x bar. Deviations of a given set of observations from what? From the arithmetic mean x bar. From this x bar we are obtaining the deviation. So this is x1 minus x bar, similarly x2 minus x bar, x3 minus x bar and so on, xn minus x bar. As such we are finding the deviations. Later on we are doing the square of them, squared deviations. So do the square of this. Suppose these deviations are d, then obtain d square. Do the square of this one, x1 minus x bar square, x2 minus x bar square and so on up to what? Xn minus x bar square. As such we are obtaining the all square of all deviations and then we will take arithmetic mean of the square of these deviations. Means we are doing summation of xi minus x bar square. We are doing this sum. We are finding this total here and divided by what? Number of observations. So arithmetic mean of squared of these deviations, that is a definition and it is denoted by what? Sigma square. So now this is I have explained for individual series distribution. So similarly for discrete frequency distribution and for grouped frequency distribution the formulas are different. So let us see the computation of variance for individual series distribution, discrete series distribution and grouped frequency distribution. So computation of variance for what? Individual series distribution. So first for individual series distribution. Now as I explained, let me assume if x1, x2 and so on up to xn are n observations on the variable x Okay. Now with the mean of them, with mean x bar, then the variance, denoted by sigma square is, what is sigma square here? As I explained, it is summation, or let me write this as such, 1 upon n summation xi minus x bar square. I varies from what? 1 to n. I varies from 1 to n. This is our formula for this. Now we can split up this a minus b whole square. According to that, the formula becomes 1 upon n summation xi square minus x bar square. This is our result, the simplification of that one. This is for individual series distribution. Now similarly we can obtain for the discrete frequency distribution. Now for discrete frequency distribution, what does that? Second, for discrete frequency distribution, if x1, x2 and so on up to xn occur with frequencies f1, f2 so on up to what? Fn, from so on up to Fn, then what is sigma square in this case? You know discrete frequency distribution. Here each observation have the corresponding frequency. So what is sigma square here? It is 1 upon capital N summation fi xi minus x bar square. This is our result here. I again varies from 1 to n, and the simplified result is here 1 upon n summation fi xi square minus x bar square. This is the result here, where what is n? N is what? Summation fi, and x bar, what is x bar? It is summation fi xi upon summation fi. X bar is this. Fine. Now the next one, for grouped frequency distribution. Now here again sigma square is 1 upon n summation fi xi minus x bar square. I varies from 1 to n. In grouped frequency distribution, you know the class intervals and the corresponding frequencies are given. Here these xi's are nothing but what? The class marks. So here let me write where n is again summation fi. Fine. X bar is again what? Summation fi xi upon summation fi. And these xi are what? Midpoints, or that are also known as what? The class marks. Midpoints or class marks of the ith class interval. Fine. These are the results of what? Variance. Sigma square is the notation for that. Fine. Now let us see the standard deviation. Now the standard deviation is very easy. It is just a square root of the variance is nothing but the standard deviation. Now let me write the standard deviation. So what does this? The standard deviation is, as I say, it is the square root, but the positive square root. The positive square root of positive square root of variance. Positive square root of variance is defined as standard deviation, and is denoted by what? Sigma, and is denoted by sigma. Therefore, what can we say? Sigma is square root of 1 upon n summation xi minus x bar square. Summation xi minus x bar square. This is for individual distribution. Now, the same result can be written as the square root of 1 upon n summation xi square minus x bar square, or that is equivalent to square root of 1 upon this capital N summation fi xi square minus x bar square. Here only this xi square, remember this thing. And this is for what? For grouped frequency distribution. For grouped frequency distribution. For grouped frequency distribution is this the result. Fine. Now this is about the standard deviation. Now here simply remember these two notes. Note 1, variance is denoted by VAR also. In short, variance of x plus a is same as variance of x, where this a is what? A is a constant. Means what? We are finding the variance of some xi's. Then we are adding the value of constant in each xi. Still the variance remains same. After doing the calculation, later on we have added one constant for each and every xi, and again we have found the variance. Still they remains same. It doesn't change. Similarly, another thing, variance of ax plus b, where what? A and b both are constants, means we have been multiplied to each and every xi by a constant, and we have added another constant is here. Then it is nothing but a square vx, where a and b are what? A and b are constant. These notes are important for small questions, simple answer questions. Now, after this, let us see the variance and standard deviation for combined group. For combined group or for combined arithmetic mean, I can say. Variance and standard deviation. Variance and standard deviation of the combined group. Now, variance and standard deviation are suitable for further mathematical treatment if we know the sizes, averages, variances, or obviously the standard deviations of a number of series of observations. Then we can obtain the variance or standard deviation of combined series also. So now here let n1 and n2 be the sizes, n1 and n2 be the sizes of two groups, having x1 bar and x2 bar as their means respectively. as their means respectively, and sigma 1 square and sigma 2 square as their variances respectively, then the variance of the group containing these observations. Which one? N1 plus N2, means we are combining them. N1 plus N2 observations. Is given by, what does that variance is given by? It has a result. Now I can see it is sigma c square, as it is combined variance. So sigma c square is what? N1 into sigma 1 square plus d1 square plus N2 times sigma 2 square plus d2 square upon N1 plus N2. Now here, where d1 is what? x1 bar minus xc bar. What is d2? d2 is obviously x2 bar minus xc bar. So we need to find xc bar here. So what is the result of xc bar? We have already taken it. It's combined arithmetic mean. It has a result n1 x1 bar plus n2 x2 bar upon n1 plus n2. This is the result for combined arithmetic mean. Fine. Now this is about xc bar. Now this is a variance, then obviously the standard deviation is what? The positive square root of this. Therefore, combined standard deviation is what does that? It is simply sigma c is what? The square root of this term, that is n1 sigma 1 square plus d1 square plus n2 sigma 2 square plus d2 square upon n1 plus n2 Again, here there are various cases. If x1 bar equal to x2 bar, then the result changes. Again n1 equal to n2, then the result changes. Also, if both of them together, then means what? x1 bar, x2 bar are same and n1, n2 are same, then also result differs. Okay, so let us see those cases here. Later on we will go for the next part. So the cases are here. Suppose the first case, case 1, that if x1 bar equal to x2 bar. If x1 bar equal to x2 bar, then obviously as the means are same, their combined mean is also what? Same. Combined means should be same. And if the combined mean same, what is d1? d1 is x1 bar minus xc bar. If these are equal, then d1 becomes 0. Similarly, d2 also becomes what? 0. It is x2 bar minus xc bar, so that also becomes 0. So if that is what? d1 equal to d2 equal to what? 0. If this is the case, then d1 d2 becomes 0. If d1 d2 are 0, then what is sigma c? Sigma c is what? Actual result is what does this? n1 times sigma 1 square plus d1 square plus n2 times sigma 2 square plus d2 square upon n1 plus n2. Means d1 d2 becomes 0 here. So this is nothing but square root of what? N1 sigma 1 square plus N2 sigma 2 square upon N1 plus N2, as x1 bar equal to x2 bar implies d1 equal to d2 equal to what? 0. This is the case 1, you can remember this. Now next thing, case 2, if n1 equal to n2, then what happens? Case 2, if n1 equal to n2, if n1 and 2 are same, then what is xc bar? Xc bar will become x1 bar plus x2 bar upon what? 2, simply upon 2. Now due to that, what happened? This is half of them. This is half part. So what is d1? d1 is x1 bar minus xc bar. So this will be what? x1 bar minus this x1 bar plus x2 bar upon 2. That is what? This is x1 bar upon 2 and this minus x2 bar upon 2, minus is this. Fine. Now again, what is d2? d2 is what? x2 bar minus xc bar. So what is here? It will be x2 bar minus, this is what? x1 bar plus x2 bar upon 2, half of that. So again this will become x2 bar upon 2 minus x1 bar upon 2. So these are what? They becomes negative of each other. So d1 equal to minus d2. That is same as d1 square equal to what? d2 square. Therefore, what is sigma c? Sigma c will become square root of n1 into sigma 1 square plus n2 into sigma 2 square upon what? n1 plus n2. n1 plus n2. So this will become here, this is what actually, let us write the first part previously. n1 into what? Sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square upon n1 plus n2. n1 plus n2. Fine. Now here d1 square d2 square are same, n1 n2 are same. So this will become n1 n2 are same, so this is twice, and here we can take it common. So it will become 2 there. Fine. Now these are same. So what does this? This is half of sigma 1 square plus sigma 2 square plus, these are same, means twice they are. So it will become d1 square. This is our result for n1 equal to n2. Then sigma c is this one. Now again, now let me combine them as a case 3. What is case 3? Case 3, let us take if x1 bar equal to x2 bar and n1 equal to n2. If this is the case, then what happened? x1 bar equal to x2 bar equal to xc bar. That gives d1 equal to d2. That is equal to what? 0. n1 equal to n2, that time d1 square equal to d2 square. Therefore, what is sigma c? Sigma c will become the square root of sigma 1 square plus sigma 2 square upon what? 2. This is what? The results for the standard deviation, variance, standard deviation and the combined standard deviation, also the combined variance. If we take the square of this, we get the variance. These are various cases I had taken for combined standard deviation according to the means are same. Suppose the number of observations are same as such. Now let us see the merits and demerits of variance. Then the same are applicable for the standard deviation also. So merits and demerits, merits and demerits of variance. So let us see the merits first. Merits, what are they? The first one, it is rigidly defined, means what? It is same everywhere, rigidly defined. Wherever it will be counted, it will be same. It is based on all observations. Here we will consider all the observation, based on all the observations. Third one, it is capable for further arithmetic treatment. It is capable of further algebraic or arithmetic treatment. Further or algebraic treatment. It is least affected. It is least affected by the sampling. Least affected by the sampling fluctuations. Sampling fluctuations. Then the next, variance is the least among all the mean squared deviations. Mean squared deviations taken from A. A is any constant here. Now next, it does not ignore the algebraic sign of deviation. It does not ignore the algebraic signs. We are taking squares here, so it doesn't affect on the deviation. So it does not ignore the algebraic sign of deviations. Now, demerits. What are the demerits? Obviously, some demerits are there. So the first one, the concept of variance is difficult to understand. If you get it, then it is very easy. Otherwise, it is difficult to understand practically. Theoretically, it is very easy. Now, second one, it gives more weightage. It gives more weightage to items deviating more from the mean. Next one, being the arithmetic mean of standard deviations of units in which variance is expressed are different than the units of original series. Now the last one is what? It is indeterminate in case of frequency distribution with open-end classes. Means what? It is not applicable for open-end classes. It is not applicable for open-end classes. Okay. Now, one more drawback of variance being expressed in different unit of measurement as compared to original series is overcome by defining the standard deviation. The standard deviation possesses all the merits of variance, hence it is regarded as the best and most powerful measure of dispersion. So, just I am giving that as a note that standard deviation is a most powerful and the best measure of dispersion. Remember this. Note, standard deviation is the most powerful and best measure of dispersion. Okay, so now here we will stop for today. In next video we will see the coefficient of variation, and also we will see the examples on all these kind, that are arithmetic mean, standard deviation, coefficient of variation. Also obviously as we see the standard deviation, we will see the examples on variance also. Thank you.